Trigonometry ratios. Suppose we are given a right angle triangle ABC, where ABC are the angles, and the side facing angles uppercase ABC are lowercase letter ABC respectively. Then the following follows. In the right angle triangle, one of the angle is 90 degrees, and that's what makes it a right angle triangle. Let this angle be A, this B, and this is C. This implies that angle B is equals to 90 degrees. Let's assume that angle C is equals to theta. That is, the angle C is equals to theta. The angle A is unknown. Then, let BC be A. If you observe, A is opposite the angle A, and the distance AC be B, which is opposite angle B, and the distance AB be C. Each of the sides of a right angle triangle has a name. The longest side of a right angle triangle is called hypotenuse. The side that is opposite to the angle theta is called opposite. It is opposite because it is in the opposite direction to the angle theta, while the last side is called the adjacent. Let us draw the triangle again. The right angle triangle. This is angle 90. That's what makes it a right angle triangle. Let it be A, B, and C. And let this angle here be theta. This is B, this is A, and this is C, which are the distance respectively. The longest side is called the hypotenuse. The side opposite the angle is called opposite, while this last part is called the adjacent. The trigonometry follows. The first one is the sine of theta, which is abbreviated as sin, also called sin theta though, is equals to opposite over hypotenuse. So it will be equals to C, which is opposite, hypotenuse is B over B. So sin theta is equals to C over B, which is opposite C and over hypotenuse B. Then we have cosine theta, which is abbreviated as cos theta, and it is equals to adjacent all over hypotenuse, and this is equals to adjacent is A over hypotenuse is B. So cosine of theta, which is cos theta, is A over B. Then we have tangent of theta, which is represented as tan theta, and is equals to opposite all over adjacent. And this is equals to opposite is C over adjacent is A. Hence, tangent of theta, which is tan theta, is C over A. We have other trigonometric functions such as the secant, which is represented by sec theta. This is equals to 1 over cos theta. If we simplify this, we have that 1 over cos theta. Recall that cos theta, which is cosine theta, is A over B. So we can substitute A over B for cos theta. A over B. This will be equal to B over A. Remember that if you have an expression such as A over B over C, this is equals to AC over B. What you have to do here, just take number at the bottom to the top. because A times C over B. If we apply this principle here, 1 over A over B, just take B up, becomes 1 times B, which is 1 over A. Hence, sec theta is B over A. We have other trigonometries like cotangent of theta. It's also represented as cot theta. It is equals to 1 over tan theta. Now this is equals to 1 over, do you remember tan theta? Tan theta is equals to C over A. So this is C over A, and if you simplify it, A will go to the top, becomes A over C. Then we have one more, cosecant of theta, which is equals to cosec theta, and this is equals to 1 over sine theta, equals to 1 over sine theta. Sine theta is C over B, C over B, and so it will give us B over C. It's very important to remember the first three trigonometries, which are sine theta, cosine theta, and tangent theta. There's an acronym that can help us remember this three trigonometry at a glance, and the acronym is the popular SOHCAHTOA. SOHCAHTOA. How does this work? This S represents sine, C represents cos, and T represents tan. O represents opposites, H represents hypotenuse, A represents adjacent, H is hypotenuse, O is opposite, and A is adjacent. Let's go back to the triangle. Triangle A, B, and C. This is angle 90. And this is B, this is A, this is C. So let's see if we will be able to use these acronyms to remember the trigonometry. The first is SO. S is for sine theta. So this implies that sine theta is equals to O. O is opposite. All over H, hypotenuse. Hypotenuse. So if you can remember, so sin theta is equals to opposites over hypotenuse. It's as easy as that. And this is equals to opposite. Opposite is, there's an angle here. So opposite is C over hypotenuse B. Remember that the longest side is the hypotenuse. The opposite to this angle is the opposite. And the last part is the adjacent. So let's go over to car. C is cos. Cos theta is equals to A, which is adjacent, over H, hypotenuse. This is equals to, the adjacent is A over hypotenuse. Hypotenuse is B. Toa, which is tan for T, is equals to O, opposite, over A, adjacent. And this is equals to opposite. Opposite is C over A. So with the acronyms SOHCAHTOA, we'll be able to remember the three basic trigonometries, which are sin theta, cos theta, and tan theta. What about the other three trigonometries? Is there an acronym that can help us out with them? The first, which is cosec theta, the second sec theta, and the third cot theta. Yes, there is a way we can easily identify them, and it lies in the third alphabet of each of them. For example, the third alphabet here is X, the third alphabet here is C, and the third alphabet here is tan. And this is how it works. Cosec theta is the inverse of the trigonometry that begins with X. And which one begins with X is sine. Hence, cosec theta is 1 over sine theta. While sec theta is the inverse of the trigonometry that begins with C, which is cos theta. Hence, sec theta is equal to 1 over cos theta. And cot theta is the inverse of the trigonometry that begins with T, tan. Cot theta is 1 over tan theta. It's as easy as this. The inverse of sine, the inverse of cos, and the inverse of tan. With this, it becomes so easy to remember the function of cosec theta, sec theta, and cot theta. Let's take some examples. Example 1. In the right-angled triangle below, find x and y. These are the two triangles. We are going to find x in this triangle and find y in this triangle. So let's solve for A first. The triangle is in this order. This is 60 degrees. This is x. And this distance here is 4 centimeters. Remember that the longest side of a triangle is called the hypotenuse. The side that is opposite to this angle is the opposite. And the last part is the adjacent. Which trigonometric function are we going to use here? The function we're going to use depends on the information that is given. In the triangle, we have hypotenuse, which is 4. Then we are looking for adjacent x. But we are not interested in the opposite because there's no information here. So we are interested in hypotenuse and adjacent. Now let's write out the acronym, which is so, ka, toi. The next step is to look at those three acronyms and find out the one that corresponds with the hypotenuse and the adjacent, which is what we are looking for. For example, in so, there's opposite, but there's no information opposite, so we don't know this one. In can, we have AH, which are adjacent and hypotenuse. This is what we're looking for. While in tan, there's also opposite, which we're not interested in. So in this question, we are focusing our attention on hypotenuse and adjacent, which is AH. So we're interested in AH. Hypotenuse and adjacent are going to make use of cos, which is cos theta is equals to adjacent over hypotenuse. And this will give us adjacent is x over hypotenuse is 4. So let's proceed. It has been deduced that cos theta is equals to x over 4. Now what is theta? Theta is the angle 60 degrees. So hence cos 60 degrees is equals to x over 4. So we need to simplify the expression to find the value of x. What is cos 60 degrees? At this point, let's move over to the calculator. Cos 60 degrees. Before taking the answer, we should always make sure that this is in degree. The calculator right now is in radian. RAD is radian. Click on it and put it in degree. Very important. So let's check again. It is equals to 0.5. Cos 60 degree is 0.5. Assuming it was in radian, it would have given us 0.5. So always ensure that your calculator is in degree to get the answer. So let's go back. Cos 60 degree is 0.5, and this is equals to x over 4. So at this point, we are going to cross multiply. This 0.5 can be written as 0.5 over 1, which means that 0.4 will times 4 and 1 will times x. 1 times x is equals to 0.5 times 4. So x is equals to 0.5 times 4 is 2. Hence, the value of x is 2 centimeters because we are dealing with centimeters. Now let's find y. From the question, the B part, we have the second triangle like this. The angle here is 30 degrees and here is 8 centimeters. We're looking for y. So in the same way, let's label each part of the triangle. The longer side is the hypotenuse. The side that is opposite to this angle, the opposite direction to the angle, is the opposite, while the last part is the adjacent. Now, which parts are we interested in? Which two parts are we interested in? We are looking for adjacent, H, and we are giving opposite, O. So we are interested in OH. We are not interested in adjacent because there's no information here. So let's go to our acronyms, which is so, ka, twa. We need OH. OH. The ones that has A in it, we don't have business with those ones, which is can and twa. But we need OH, which is sine. So hence, it becomes sine theta, which is equals to opposite O over hypotenuse H. And this is equals to opposite. Opposite is 8 over hypotenuse. Hypotenuse is y. So we have that sine theta is equals to 8 over y. Theta is 30 degrees. So sine 30 degrees is equals to 8 over y. What is sine 30 degrees? Let's move over to our calculator. The calculator, the mode is in degree. So let's click on sine 30 degrees. Still 0.5. So let's go here. Sine 30 degrees is 0.5. This is equals to 8 over y. 0.5 is equals to 8 over y. 0.5 over 1, which is the same thing, we cross multiply. It becomes 0.5 y is equals to 8. Now the next step, we divide both sides by 0.5. 0.5 cancels 0.5, y is equals to 8 over 0.5 will be 16, so y will be equals to 16 centimeters. That is the answer. Example 2. Given that sine theta is 8 over 17, calculate the value of cos theta, tan theta, and cos theta plus sin theta all over cos theta over sine theta. So there's a question. Let's proceed with the solution. We are given that sine theta is equals to 8 over 17 from the question. Now remember the acronyms, which is so, ka, twa. Where sine theta here is equals to opposite, which is O, over hypotenuse, which is H. And this is equals to 8 over 17. And this implies that the opposite is 8, hypotenuse is 17. Now applying this into the triangle, the right angle triangle, where this is the hypotenuse, this is the opposite, and this is adjacent. We have that opposite is 8, the distance here is 8, and hypotenuse is 17, here is 17. So we have to find cos theta and tan theta. It's quite easy, but the first step is very important that we calculate the adjacent. With this information given, which is 8 and 17, we will be able to calculate for the adjacent. Now, how are we going to do this? We'll make use of Pythagoras' theorem. Pythagoras' theorem states that if we have a right angle triangle, let's get this distance be A, this is B, and this is C. Now, take note of the longest part, which is hypotenuse A. We have that the longest part square is equals to the square of the other two sides of the right angle triangle. So this is Pythagoras' theorem. Now applying this in the question that we have, triangles look like this. This part is 17 and here is 8. And we're looking for A, which is the adjacent. So let's substitute this in a formula. The square of the longest part, 17, is equals to the addition of the square of the other two parts, which is 8 squared plus A squared. If we simplify this equation, we'll be able to get the value of A. So let's proceed. Well, 17 squared is 289. This is equals to 64, which is 8 squared plus A squared. We're going to take like terms, which is 289 minus 64. This is a whole crossover and become negative. It's equals to A squared. 289 minus 64 will give us 225. This is equals to A squared. So we have that A squared is equals to 225. Now to find A, we need to find the square roots of both sides of the equation. A squared is equals to 225. The square root of this and the square root of this will cancel square. So we're left with A is equals to, the square root of 225 is 15. So we have the value for the adjacent, which is 15. So let's proceed to draw the triangle again. At this point, we have all the information we need. The longest side is 17, which is the hypotenuse. Opposite is 8, and the adjacent is 15. What are the trigonometries we are looking for? From the question, we have to find cos theta. Now, let's remember that from SOHCAHTOA, which is SOHCAHTOA, cos theta is AH, which is adjacent over hypotenuse. And this will give us adjacent is 15. Let's label it. This is hypotenuse, the longest side. This is opposite, the part that is in the opposite direction to the angle, and this is the adjacent. So adjacent is 15 over hypotenuse is 17. So therefore cos theta is equals to 15 over 17. We are going to find tan theta. From SOHCAHTOA, when dealing with tan is AO. Yes, tan theta is equals to A adjacent over O opposite. So we have that tan theta is equals to adjacent. Adjacent is 15 over opposite, and opposite is 8. Tan theta is 15 over 8. At the last one, we are going to find cos theta plus sine theta all over cos theta minus sine theta. This will be equals to cos theta. We have cos theta already, and cos theta is 15 over 17. 15 over 17 plus sine theta. Sine theta from the question is 8 over 17. 8 over 17 all over cos theta is 15 over 17, and sine theta is 8 over 17. It's a very, very simple equation since all the numerators are same. So 15 over 17 plus 8 over 17 is 15 plus 8 over 17. Just follow. And 15 over 17 minus 8 over 17 is 15 minus 8 over 17. So if we simplify further, 15 plus 8 is 23 over 17 all over 15 minus 8, 7 over 17. Hence, we have 23 over 17 all over 7 over 17. This is equals to 23 over 17 divide 7 over 17. There's the division sign here. If we simplify further, 23 over 17, we can easily convert this division sign to multiplication sign. Then we're going to reverse these two numbers. 17 will go up, and 7 will come down. So this will give us 23 all over. At this point, 17 will cancel 17. So it's 23 over 7. And we know that 23 cannot be at the top of 7 because it's smaller. So hence 7 go to 23 3 times, remainder 2 over 7. And this is the answer. Example 3. If tan theta is equals to 5 over 12 and 0 is less than theta less than 90 degrees, find 1. Sine square theta, 2. Cos theta minus sine theta, and 3. Cosec theta. Now let's proceed. From the question, we are given tan theta is equals to 5 over 12. Now remember the acronyms, which is so, ca, toi. Tan theta here is equals to opposite over adjacent, and this is equals to opposite. Where's opposite? Opposite is 5 over 12. Tan theta is 5 over 12, so this implies that opposite is 5 and adjacent is 12. So let's input this information into the triangle. In the triangle we have this angle 90, this is theta. If we are to identify each part, this is the hypotenuse, this is the opposite, and this is adjacent. So opposite is 5, opposite 5, and adjacent is 12, adjacent is 12. Hence, we need to find the longest part, which is hypotenuse. So, using Pythagoras theorem, 5, 12, we're looking for h, which is the hypotenuse. Pythagoras theorem states that the square of the longest part, which is h square, is equal to the square of the addition of the other two parts, 5 square plus 12 square. So h square is equal to 25 plus 144. H square is equal to 169. H square equals to 169 we'll find the square root of both sides. Square root cancels square, so h is equals to 13. Hence, if we draw the triangle one more time, we have that here is 5, which is the opposite. Here is 12, which is the adjacent, and the hypotenuse is 13. So with this, we'll be able to find sine theta, cos theta minus sine theta, and cosec theta. So let's move over to the next page. Let's draw the triangle first. 5, 13, and 12. We are looking for sine square theta. We should take note that sine square theta is the same thing as sine theta square. Our acronyms remains so, ca, toi. And sine theta is equals to opposite over hypotenuse. And this will give us opposite 5. Hypotenuse is 13. Let's liberate. The longest side is the hypotenuse. This is the opposite. And this is adjacent. So, we have that sine theta is equal to 5 over 13. Sine theta is equals to 5 over 13. And so, sine square theta, which is equals to sine theta all square, will be equals to 5 over 13 all square, equals to 5 square over 13 square, equals to 25 over 169. And that is for sine square theta. So let's move over to cos theta minus sine theta, which is II, cos theta minus sine theta. Cos theta, remember that so, ca, toi is the acronym. So for cos theta is equals to adjacent, which is A, over hypotenuse, which is equals to adjacent. Adjacent is 12. Hypotenuse is 13. Y for sine theta, we solved for it before. So sine theta is 5 over 13. 5 over 13 here. So this is 5 over 13. So cos theta minus sine theta will give us 12 over 13 minus 5 over 13. It's easy. This is equals to 12 minus 5 over 13. And this will give us 7 over 13. That's the answer. So let's move over to III. We're looking for cosec theta. Remember that cosec theta is equals to the inverse of one of the three basic trigonometry, which is sine, cos, and tan. But which one exactly? It lies in the third alphabet. Hence, cosec theta is 1 over the trigonometric function that begins with x, which is the third alphabet here. And the trigonometric function that begins with s is sine theta. So applying this will gives us 1 over sine theta. Sine theta is equals to 5 over 13. So this will be 5 over 13. I remember when you have three numbers in this order, just take the third one upward. Hence it becomes 1 times 13 over 5. And this will give us 13 over 5. Of course, 13 is bigger, so we're going to simplify further. 5 will go to 13 2 times, from that 3 all over 5. That's the answer. In my next video, we are going to discuss the relationship between trigonometry ratios. You can click on the link above this video to access that very video. In the meantime, if you have any question related to trigonometry ratios, you can message me directly on WhatsApp. Subscribe to my channel, like and share this video. I will see you in my next video.